All right, ladies and gentlemen, let's take a look at those three. So it looks like some people are getting all three of them. Some people got like one or two. Everyone's at least getting one of those down, depending on which one, just depends on you. But let's go through these three. So the first one, we have PB plus FeSO4 makes PbSO4 and Fe. What kind of reaction did we say this one was?
Single replacement.
Single replacement is perfect. And that's going to be a single replacement because we have an element, we have lead all by itself, and then we have a compound, which is iron sulfate. And the lead is replacing iron, and iron's just getting kicked out. There has nowhere else to go. It doesn't have anybody to go back to. So it's just going to be all by itself. So we end with a compound and an element, which is why we know it's a single replacement. What about number two, that second one?
Decomposition.
Decomposition is awesome. So it's decomposition because we have calcium carbonate, CaCO3, and it's breaking apart. It's only got one reactant and it broke down into two products of calcium oxide and carbon dioxide. So we're breaking one down into two, which makes it decomposition. And last but not least, the third one.
Combustion.
Combustion is right, and it's combustion because we have some fuel source plus oxygen makes CO2 and H2O. I know that one was probably a little confusing because normally we just see it's C and H compounds together, some sort of CH molecule, but that oxygen being there does not stop it from being a fuel source. If you see an oxygen present, it still does work as a combustion reaction. As long as we're using some fuel source reacting with oxygen. So any CH with other elements can be on there, and it's making CO2 and H2O. We should know that that makes our combustion reaction. Any questions on that? All right, so then let's take a look at your assignment for today. Your assignment for today is on balancing and molarity. So first, this one's going to be a 2-day assignment. So today what we're going to do is we're going to go through the first 2 pages through question 5 right here. So you can stop before you have to get all the way down. So we're going to stop right there at balancing with molarity, just so you're all aware. There we go. We're going to stop right there. Now, if we take a look, the first set of questions is just practice with molarity, because let's see, we haven't really done molarity as a whole since way back in first semester. So we got to remember what molarity is. And if we remember, molarity is a quantitative description of a solution's concentration. So what that's telling us is that it is going to tell us the number of moles per liter of a solution. And so we have an equation when we solve this, which is M for molarity equals moles of the solute divided by the liters of the solution. And there are some key things we need to remember here. The first thing is, if we are given grams of something, we do need to convert using our molar mass. We would need to convert from grams to moles before we can use it in our equation. The other thing we need to remember is sometimes we're given milliliters or centiliters instead of liters. And we need to make sure that our units for the bottom are going to be in liters before we use that part of our equation. So we just need to double check our units before we do any of these problems to make sure that we're doing them correctly. So let's take a look. We'll do one together, or maybe two, to refresh our memory on what's going on. And so the first one says we have 0.5 moles of sodium chloride is dissolved into 0.05 liters of solution. So how are we going to set this one up? How about this? Let's write down what givens we have. So what are we given in this problem? Somebody tell me something we know.
The liters of solution.
The liters of solution. So let's write down the liters. So 0.05 liters of solution. I'm going to abbreviate solution right there. All right, what else do we know?
The moles.
We know the moles. We know it's 0.5 moles. All right, what are we looking for then?
Molarity.
The molarity, perfect. So we're looking for molarity. So let's use our molarity equation. Molarity equals moles over liters. Do we have the moles and do we have the liters?
Yes.
Perfect, so let's plug them in. So we're gonna plug in the 0.5 moles divided by the 0.05 liters. And we're gonna solve for our molarity. What is our molarity going to be?
$10.
10, perfect. 10 molar. Perfect. 10 M. Molarity is 10. Do we have any questions on that? Do we want to do one more together, or do you guys think you can do that section on your own? All right, I'm gonna take that as we're good. All right, I do want to go over one more thing before I let you guys work, and that's gonna be the next section right here. Oh man, my picture didn't come in. Do you guys have a picture there? Can you guys see a picture?
No.
What? Oh my goodness, that's so sad. All right. Well, I put a picture there at one point. Give me 3 seconds. Thought it looked weird. All right. So the picture says a couple things. So I'm going to write down what it says because then we're going to, because it's going to be the steps that we're going to follow. So then when writing chemical equations, all right, we have 3 steps. Step number 1, identify the reactants and products and place them in a word equation. Step number 2, convert the chemical names into chemical formulas and write the states of matter. And step number 3, balance the equation. And there is a small hint to remember, so I'm going to write that right here. Hint. Remember that produced or made is a yield sign or the arrow separating our reactants from our products. Do you have any questions on those steps? I know that's a lot, so I'll give you guys like 30 more seconds of just time to write. And then I do want to talk about one thing. All right, so step number, most of this we've already done before, but there is one slight thing I do need you guys to pay attention to, and it's the number 2 where it says we're converting the chemical names to chemical formulas and writing the states of matter. So that states of matter part is new to us, and that's going to be super, super important. And it's super important because we are going to be writing down if to make sure that that reaction happens in the future. So for now, we're just going to write down the states of matter next to it. But in the future, we're using it to identify if the reaction is going to happen. So when we start predicting the products, we'll use that to determine, does this reaction occur or does it not occur? So in order to do this, we need to remember what the states of matter mean. So can anybody tell me a state of matter? Or know what a state, which, there are 3 of them.
Liquid.
Liquid is one.
Solid.
Solid is another one.
Gas.
Gas, perfect. Our 3 states of matter, wonderful, amazing. So that might even be something we want to write down here. We have solid, liquid, and gas. There's actually going to be one more that we have to include in these chemical formulas, and that's when we dissolve or we make a solution. So we dissolve our solids into a liquid. And so you might recognize this because it was on your formative, but the 4th part we're going to have to remember is aqueous. So AQ is going to be our symbol for it, and AQ stands for aqueous. And that's going to be when a solid is dissolved in a liquid or in solution. So most of the time, aqueous is going to be the one we're talking about because most of these are going to be solids that we've dissolved into our solution. So we're going to have to use those symbols as well to include them in our balanced chemical equations. So let's do this first one together using all these steps. So step 1 says to identify the reactants and products and place them in word equations. So let's do that. Which ones of these are the reactants and which ones are the products? So let's do that for number 1. So it says lead 2 nitrate reacts with sodium bromide to produce lead 2 bromide and sodium nitrate. Write out the balanced equation for the reaction. So which ones are reactants?
Lead nitrate.
Lead nitrate's a reactant, perfect. Any
and
other one?
Sodium bromide.
Sodium bromide, awesome. And then which ones are products?
Lead bromide.
Lead bromide.
and sodium nitrate.
And sodium nitrate. Awesome. So it says for number one, we're writing them down in word equation form. So let's write it down. So we have lead to nitrate plus sodium bromide. And it produces lead to bromide and sodium nitrate. All right. So now step two, we have to write them the chemical names to chemical formulas. So we have to do that for all four of our chemicals. So guys, take about a minute and a half to go ahead and do that on your own. And then we'll go through it together. All right, did anybody come up with the chemical formula for nitrate? Or lead to nitrate, sorry.
I think it's PB,
Hmm?
and then in parentheses NO3,
Yeah,
and then outside parentheses 2.
perfect. All right, nice job, everybody who told me that answer. And then the next one, sodium bromide. Perfect, perfect, and A, B, R. And then it yields or makes lead to bromide. Who's got that one for me?
Is it PBBr2?
It is, nice job. And then last but not least, we have sodium nitrate.
Na parentheses NO3.
Perfect. We can put it in parentheses, makes it perfect. If you don't want to put the parentheses there, you don't have to. It is up to you, but either way, it is right. All right. So before we can balance this equation, it does say we need to write the states of matter. So where do you think we're going to look to try and identify these states of matter? If you had to guess, doesn't have to be the right guess. If you had to guess somewhere, and take a thought about when we talked about molarity and calculating that, because that might have something to do with where we look. The periodic table is a great thought. So that one is not going to tell us unless we're talking about our gases, but that is going to be one place that we're talking about our gases. It is there technically because these guys over here are our gases. So these guys over here are going to be like the ones that we have to worry about in terms of being a gas, except for bromine. Bromine is a liquid. And we can see that as far as anything in red on our periodic table is a gas. So if it's written in red, so all these guys up here at the top and these guys right here, and then hydrogen are gases by themselves. There's going to be another place we're going to look, especially when we're talking about compounds, to look to determine what kind of symbol or state of matter we're going to be in. Let's talk about it this way. So when we're doing reactions, do you think we're going to take two solids and we're going to put them together and they're going to react usually? Yes or no? If I take two solids and I just put them on top of each other, are they going to react? Do we see that happen often? No, it does not happen often. Solids don't usually react with one another. It does happen, but not as often as we would like, which is probably a good thing because if solids just reacted when they touched, that'd be a lot more dangerous for us. And so they're not solids. So what else could they be?
Gases, liquids, or aqueous?
Gases, liquids, or aqueous. Perfect. And these guys right here, I'm going to tell you that normally I can find lead nitrate, lead 2 nitrate, and sodium bromide. I find them on a shelf and they come in like a little container and they're white powders or they're a yellow powder. So they're powders normally. How am I going to get them to react with one another?
You put them in a liquid solution.
Awesome. We're going to have to put them in a liquid solution. So we're going to have to check their what? We're going to check where to see if we put them in a liquid solution, they'll turn into an aqueous solution. Where do you think we have to check to figure out if it's aqueous or not? Remembering that aqueous is when a solid dissolves in a liquid or a solution.
Molarity.
We're going to check the molarity. Okay, so we will in the future need to know our molarities, but where do we check to see if a solid will or will not dissolve in solution? Where do we have to look for that?
Solubility.
The solubility chart. So we got to go to that wonderful thing. This lovely thing, you guys' favorite thing probably. And we have to check our solubility. So we talked about lead 2 nitrate, which is over here. And so lead 2 nitrate, what does it say about lead 2 nitrate?
Soluble.
Soluble, which means it does what? What's happened if it's soluble?
It dissolves in the liquid.
Perfect. It's dissolved in a liquid, which means we can consider that an aqueous solution. So we're going to put right next to it as a little, next to the subscript, it's going to go as AQ for aqueous. We're going to do the same thing with sodium bromide. Find sodium bromide and tell me if it's soluble or insoluble.
Soluble.
It's soluble. It's right over here. It's soluble, which means it is also going to be aqueous, which is perfect because that means they're going to react with one another. And now we have to identify these guys over here. So guys, take about a minute for lead to bromide, which I wrote wrong. And I see that now. Somebody told me the right thing, and I didn't write it down right. And then lead to bromide and sodium nitrate. Determine if they're solids, liquids, gases, or aqueous. Tell me what you think. Awesome. So lead to bromide is slightly soluble. And what about sodium nitrate?
Soluble.
It's soluble. Perfect. All right. So now that we know that, we have to think about what slightly soluble means. We know this one has to be aqueous because it's soluble, but slightly soluble. When we're talking about slightly soluble, we're going to assume for most cases that if it's slightly soluble, that means it's not going to be soluble enough all the time to make it an aqueous solution. And if it's not an aqueous solution, what does that mean? If it's insoluble, what does that mean?
They don't react.
It doesn't dissolve in solution. So that specific one's not going to dissolve in solution, which means what is it going to be? If it didn't dissolve, what is it? A solid. Perfect. It is a solid because it's not dissolving, which means it's just a solid that's floating around in a liquid, which does in fact happen, and it's crazy, I know. But we'll see some examples of that in the future. But it's going to be a solid that doesn't dissolve into a liquid, so it's a floating around inside the liquid, which is kind of like your separation lab with your salt, except for this time it can be like intermixed. It's not just all floating on top or sitting on the bottom. It's kind of floating all throughout our solution, all throughout our liquid. And this is a good thing. We want to have one of our products to be a solid because do you remember what it's called when we have a solid that didn't dissolve in a liquid? Do you remember what that's called in terms of our signs of a chemical change? I know that was the third day of school, so you might not remember it. Does anybody remember it? All right. If we see a solid formed in a reaction, it is called a, oh man, I always spell this one wrong. Precipitate. And is a sign of a chemical reaction. So it's a precipitate, which is one of our 6 signs. I think they might have given you 5 signs in your video of a chemical reaction or a chemical change has occurred. So we know this is going to be a full reaction because a solid was formed. And so for now, assuming all of them are going to form reactions, but you still need to determine their states of matter, and then you do need to balance these at the end. Does anybody have any questions on anything we just went over today? I know it was a lot. Do you have any questions on it? All right, so then try and do a couple more of these problems, finish up this balancing and then do a couple more of these problems. Tomorrow we are going to be working on this worksheet again. So we're going to be doing this. So we have those 4 other problems with practicing molarity. You have the 4.5 other problems with your writing the balanced equations. And then there's going to be 5 more problems below on balancing with molarity. So then you'll have to do both parts. So make sure you guys are working on trying to get a few more of these done. If you guys have questions and you want to stay, awesome. Otherwise,